Welcome you all. In this session, let us learn about block diagram modeling of control system. The contents are the introduction, second is the feedback system, next the general block diagram representation. First, let us see what is block diagram model. So in my previous video, you might have observed that a control system was represented mathematically by a set of differential equations, and we had applied Laplace transform to those differential equations wherein we had obtained the transfer function of that particular system. So which is nothing but the solution to the set of differential equations. So this control system actually, which is dynamic in nature, is usually concerned with the control of specific variables. So the interrelationship of the controlled variable to the controlling variable is very much required. So this relationship between the controlled variable and the controlling variable is usually represented in terms of transfer function. So this transfer function concept is very important. So what is this transfer function? It gives the relationship between the input and the output variables. So this transfer function, we represent it in the form of a diagram which is called as block diagram. So block diagram is nothing but it gives you a pictorial representation of the interrelation between the different components in the system. So we are representing it in the form of diagram. And these block diagrams are actually unidirectional operational blocks which represent the transfer function of the variable under consideration. And this block diagram for a given system is not unique. That means we can have different block diagram representation for a given control system. So you have say one control system, we can have different ways of representing it in the form of block diagram. So this is the canonical form of representing a system, canonical form of a feedback system. You can see here we have R of S, E of S, B of S, C of S. What is this R of S, E, C of S and all? This C of S is the output, okay? R of S is the input, E of S is the error signal, and B of S is the feedback signal. G of S and H of S represents the gain in the forward path and feedback path. G of S is the gain in the forward path, H of S is the gain in the feedback path. So here this particular point actually we call it as a summing point, okay? And here you can observe we have taken the signal, that is the output signal, back to the input. This is called as the takeoff point. This is the summing point where all the signals are being added. Here the signal is being tapped. This particular point we call it as a takeoff point. So what is summing point, what is takeoff point, we'll see it later. Right now we'll see what is a positive feedback system and a negative feedback system. You can observe here B of S, which is the feedback signal, is given to the summing point wherein the sign is negative. That means our feedback signal B of S is subtracted from the reference input, which is R of S. So this is called as a negative feedback system. So I repeat, if the feedback signal B of S is subtracted from the reference input, which is R of S, then we call it as a negative feedback system. If in case our feedback signal gets added to the reference signal, then we call it as a positive feedback system. But right now we will concentrate on the negative feedback signal. Okay, so this is nothing but, as I've told, it is the canonical form of a feedback system. So here the sign, if it is not given, by default it is plus. Okay, So this is the summing point, and this particular point is the takeoff point. So now what we do is we try to obtain the closed loop transfer function. This is a closed loop system. We try to obtain the closed loop transfer function, which is C of S by R of S. And we can represent it in terms of a single block, which is having output C of S and R of S. So instead of representing it as a two different blocks having gain G of S and H of S, we can represent it in terms of a single block with output C of S and input R of S. So how do we obtain it? So let us derive. So the error signal E of S is equal to R of S minus B of S. So the feedback gain, which is H of S, we write it as the output of the feedback, which is B of S, by input to the feedback, which is C of S. So B of S is equal to C of S into H of S. That B of S we substitute here. Okay. So this becomes E of S is equal to R of S minus C of S into H of S. Now what is this error signal? So the forward gain G of S, we can represent it as the output of it by the input to the block, which is E of S. So E of S is nothing but C of S by G of S. So this particular thing we substitute it here. So what are we going to get? C of S by G of S is equal to R of S minus C of S into H of S. So that we can write C of S is equal to R of S into G of S minus C of S into H of S into G of S. Okay. So we have two terms which contain C of S. One is the left hand side and the other one is in the right hand side. So we take it to the other side. So what it is going to become? So we can write C of S into C of S into 1 plus H of S into G of S is equal to R of S into G of S. So the output C of S by R of S, we can write it as G of S divided by 1 plus G of S into H of S. So G of S by 1 plus G of S into H of S. So the entire canonical form of feedback system, we can write it in simple one block representation, which has a transfer function G of S by 1 plus G of S into H of S. So we have this as our canonical form of feedback system, to which we have obtained a single transfer function, which is of the form G of S by 1 plus G of S into H of S. So here C of S is the output and R of S is the input. So this is what we have seen. So this is for a negative feedback system. If it is a positive feedback system, what is the change? Change over here is this, instead of minus, this sign becomes plus, and the transfer function for a positive feedback system will be positive feedback system will be G of S by 1 minus G of S into H of S. Only thing what changes is the sign in the denominator is going to change. So this ratio of E of S by R of S, we call it as the error ratio. Okay, E of S by R of S ratio, we call it as error ratio. So if this h of s is equal to 1, if the h of s is equal to 1, or we don't have this block, directly the output is taken and given back to the input, then that we call it as a unity feedback system. So if the output is taken directly and given back to the input without any gain, then we call it as a unity feedback system. So the next we'll see how do we represent a general block diagram. So general block diagram, actually we can represent it in a form of a simple block, okay, which has a transfer function which gives the relation between the output y of s and the input x of s. So as I have already told you, there are 2 points in the block diagram. One is the summing point and the other one is the takeoff point. So summing point or a summing junction is the one where signals are added together, whereas a takeoff point is the one from where a signal is taken to some other part of the diagram. So here you can observe the summing point. I have given 2 diagrams over here. The signals are being added algebraically. The R of S sign is not specified, but I have told you by default it is to be treated as positive sign. So if we treat it as a positive sign here, then what is the signal which is coming, which is taken out here? It is R of S minus X of S. Similarly here, the second diagram, if you observe, the default sign is plus. The signal over here is R of S minus X1 of S. So to that, X2 of S gets added up. So the entire signal becomes R of S minus X1 of S plus X2 of S. So this is about the summing point where your signals are added algebraically. Whereas a takeoff point or a pick-off point is the point from where a signal is taken to other part of the block wherein the original signal remains the same in magnitude. So if you are taking the signal X of S, then the signal which is taken to the other part of the diagram also has the same magnitude, which is equal to X of S. So this is where you can observe only one takeoff point is there, but here you have one takeoff point wherein you have given it to the 2 different places of the block diagram, but the magnitude of the signal remains the same. So this is regarding the general block diagram wherein you will have the summing points and takeoff points. So we have seen what is block diagram, how it is being represented, what is a positive feedback system, what is a negative feedback system. So whenever we have a complex system, complex control system, we cannot write several differential equations and analyze the system. In that case, we can go for a block diagram method wherein the transfer function of each component will be given and you can obtain the transfer function for the entire system. So in the next video, we'll see the block diagram reduction rules. Thank you.